In this video, we're going to be going over how to determine if an ordered pair is a solution to the system of linear equations, and also how to determine what the solution is to a system graphically. So we're going to start here with our first problem. We have the ordered pair 3, 1, and the equations x plus y equals 4 and 2x minus y equals 3. So we're going to start off by labeling our points, so x and y, and then what we'll do is we'll take those and we're going to want to put those back into our equation to check them. So we'll take our first equation, x plus y equals 4, and we'll plug in our 3 and our 1. Then we'll work that out and see that 3 plus 1 equals 4. And so we can see that, yes, this works here. So now we're going to take our 2x minus y equals 3, and then we're going to plug in our x and our y so that we've got 2 times 3 minus 1. And then we're going to work that problem out, and we're going to see that that's going to give us a 5. And 5 does not equal 3. So that tells us that we're going to have a no here. So this is not going to be a solution to our system. So really it's all about plugging in your points and making sure that you get a yes for both equations. If one of your equations is a no, your answer is going to be no, it's not a solution. So I want you to try letter B on your own. So push pause and work out the problem, and then when you're done, push play, and let's see if you were right. So we start by labeling our points, 1, 3 as x and y, and then we'll be plugging them in. So we'll start with our first equation, x minus y equals -2, where we will plug in our 1 and our 3. When we work out 1 minus 3, we get an answer of -2, and we see that that matches. So it's a solution to our purple equation, or our top equation. But is it a solution to our bottom equation? So now we'll take the 2x plus y equals 5, and we'll plug in our x and our y values. So we want to know, is 2 times 1 plus 3 going to equal 5? And when we work it out, we get a 5, which in fact matches a 5, which tells us that yes. And so because both of our solutions, rather both of our equations work with the points 1, 3, we can see that that is going to be a solution. What about graphically though? So if we're thinking about graphically, we're going to use the graph to solve the system of linear equations. So as we look at this here, we're not going to worry so much about checking our solutions. I've already checked them, and how we check them is what we just got done doing. So notice that it gave us our equations, right? It gave us both of our sets of equations, but because it gave us the graph, we don't really need the equations except to check our answers. So we're just looking for where the two lines or the two functions intersect. And so here we see that we have an intersection point at 2, -2, and that is the solution to our system. And when we plug it back into the purple equation and the green equation, it works. So for problem B, again, it gave us both equations, but because it gave us the graph, we don't need the equations until we're ready to check our solutions. So we're going to look for the intersection point, which here is at -1, -3. And when we plug that back into those equations, we see that it works. I want you to do problem C on your own. So push pause, work out the problem. When you're done, push play, and let's see if you were right. So for problem C, again, it gave us both equations, which we don't need until we go to check our solutions because it gave us the graph. So on our graph, we see that we have an intersection point at 4, 2. So that's going to be the solution to our system. So how do you solve a system of linear equations graphically when it doesn't give you the graph? We're going to look at that next. So here we've got 3 different examples. So in this one, we have both of the equations, but no graph. So what we're going to do first is we're going to take our first equation, y equals -x plus 3, and we're going to find the m and the b for that equation. So we'll have an m of -1 and a b of 3. Now we'll look at our second equation, y equals x plus 5. We're going to find the slope and the y-intercept for that equation as well. And so we're going to have an m of 1 and a b of 5. And now we're ready to graph. So we're going to graph our top equation first. So we're going to go to our starting point, which is the 3, because that's our y-intercept, and put our point there. Now our slope is down 1 over 1. So we're going to go down 1 over 1, down 1 over 1, down 1 over 1. Then we're going to go ahead and draw our line. Then we're going to graph our bottom equation. So we're going to start at 5, so there's a y-intercept of 5. and then we're going to graph up 1 over 1, up 1 over 1, up 1 over 1, and draw our line. And our intersection point is going to be the points where the two lines or the two functions come together, which in this case is negative 1 comma 4. Let's take a look at example B. So again, here we have two equations, y equals 1/2 x plus 2 and y equals negative 1/2 x plus 4. So we'll start by finding the m and the b for our top equation. So we have a slope of 1/2 and a y-intercept of 2. In our bottom equation, we have a slope of negative 1/2 and a y-intercept of 4. So we're going to graph our top equation first. So we'll put a y-intercept at 2, because that's what our b value is. And then we're going to go up 1 over 2, up 1 over 2, and draw our line. Then we'll graph our bottom equation. So we're going to start at 4 because that's our y-intercept. We're going to go down 1 over 2, down 1 over 2, down 1 over 2, and finish our line. And the point where they intersect is at 2 comma 3. Now problem C is a little bit different because as you look at it, our top equation, 3x minus 2y equals 6, isn't in the slope intercept form. So that's going to have to be something that we do first. But our bottom equation is, and so here we have a slope of 0 and a y-intercept of negative 3. So we're ready to kind of tackle this other equation, 3x minus 2y equals 6. So we're going to get the y by itself. So we're going to begin by subtracting 3x from both sides. Then we have negative 2y equals negative 3x plus 6. Then we'll divide everything by negative 2 to get the negative 2 to go away. From here, we'll have y equals a 3/2 x minus 3. So here, we'll have an m of 3/2 and a b of negative 3. And now we're ready to graph. So we'll graph at negative 3 because that's our y-intercept, that's our b value. And our slope says up 3, 1, 2, 3 over 2. So up 3 over 2. And then we'll go ahead and we'll do it again. Up 3, 1, 2, 3 over 2. And that gives us our line. Then we can graph our other equation. It has a slope of 0 and a y-intercept of negative 3. So we'll start at negative 3. And it says up 0 over 1. Up 0 over 1. And we can graph that line. And so here we see that we have an intercept or an intersection point at 0 comma negative 3. And so that is our solution point. And so that's how you determine if a solution, an ordered pair, is a solution, how you can determine what the solution is when you're given the graph, and how to determine what the solution is when it gives you the functions by graphing.